In this video, we will see potential due to point charges. In last videos, we saw what is work done, what is potential at that point, what is potential difference, and what is line integral. So, if you recall in last video, what is potential? Potential is a work done to move a unit charge from infinite to particular point. So that is called potential at a particular point. Now, to find potential due to a point charge, so when I move the charge from point B to point A, then what is the potential at that particular point due to a point charge if the point charge is placed in origin. So consider this diagram here. See here, this charge Q is a point charge which is placed at the origin. This charge Q is placed at the origin. So this charge is placed at origin. Now this charge will produce the electric field intensity in a circular manner, in a spherical manner. The electric field intensity produced, the field lines produced from this charge will be in a spherical manner. So I am considering all the derivation in spherical coordinate system. So because the electric field produced from this charge Q in a spherical manner, so I am considering all the fields are radially moving outward. So I am considering spherical coordinate system, and so I want to find what is the potential at this point charge. What is the potential due to this point charge on point A when I move a unit charge from point B to point A? When I move a point charge unit charge from point B to point A, what is the work done to move the unit charge from point B to point A due to a field produced from this point charge? So I am considering this point A. This point A is placed at a distance of RA from the origin, and point B is placed at a distance of RB from origin. Now we know that the electric field produced from the point charge can be written as E is equal to Q by 4 pi epsilon naught into R square into AR cap. In general, we can write the electric field intensity produced from a point charge Q can be written as E is equal to Q by 4 pi epsilon naught R square into AR cap. This is a direction vector, unit vector. Now we have to find what is the potential when I move the unit charge from point B to point A. So which is at the point A is at a distance of RA and point B at a distance of RB. Now we know that what is the work done or what is the potential at the point A can be written as before going to potential expression I am considering, because I am already told that this point charge, the field produced from point charge, I am considering spherical coordinate system. So the differential length in a spherical coordinate system dl vector can be written as dr into ar cap plus r d theta into a phi cap plus r sin theta d phi a phi cap. Now the work done can be written as, or potential at the point can be written as VAB, that is the unit positive charge, the work done when we move unit charge from B to A can be written as, so VAB, which is equal to minus integral of B to A E dot dl. So we know E, we know dl, so substitute both. So you will get VAB is equal to, but what is the length of movement here? So length is what is the length of point A from origin is RA, and what is the length of B from origin is RB. So the integration limit will be from RB to RA. So Q by 4 pi epsilon naught R square into AR cap dot dr AR cap plus r d theta A theta cap plus r sin theta d phi A phi cap. So we know that AR cap dot A theta cap is 0, AR cap dot A phi cap is 0. Only the R terms remains here. So the integration will be VAB integration over limit RB minus RB to RA Q by 4 pi epsilon naught R square into dr. Now if you integrate this, so you will get r to the power minus 1 divided by minus 1 over the limit RB to RA, and substituting the limits you will get, so Q by VAB is equal to Q by 4 pi epsilon naught into 1 by RA minus 1 by RB. This is the expression for the potential due to a point charge. So when RB is greater than RA, then we will get the positive potential difference, and when RA is less than when RA is greater than RB, then you will get negative potential difference. So this is the expression for potential at a point due to a point charge. So VAB is equal to Q by 4 pi epsilon naught into 1 by RA minus 1 by RB. RA is the length of the point A from origin, and RB is length of point B from origin. So potential difference due to point AB can be written as VAB is equal to Q by 4 pi epsilon naught into 1 by RA minus 1 by RB. Now, in normal circuit, we will represent the potential of particular point with respect to some fixed point. So, we will represent normally potential, we will measure taking a fixed point. Normally, in a practical circuit, we will take the point as a fixed one. The one point is fixed, other point we will measure other point with respect to that point. So, in normal circuit, we will take that. In practical circuit, that point, fixed point, is known as ground or earth. So here, so the potential which is measured due to a specified reference point, the potential which is measured due to a specified reference point is termed as absolute potential. If the potential is measured from a particular specified reference point, is known as absolute potential. The absolute potential is measured with respect to fixed reference point. So the reference point, as you know, in a practical circuit, we will take the ground as a reference point. So normally ground has a zero potential. Similarly, the fixed reference point also has a zero potential. So it is similar to what we consider ground as a reference point. It is similar to when we measure potential from ground to other point is called absolute potential. If I take this wire, if the outer shield of this wire is conductor is grounded, then if I measure the potential between this point to this point is called as absolute potential. If I measure the potential from this point to this point is named as absolute potential. So absolute potential means the is measured with respect to fixed reference point which has a zero potential. Now we know that expression for the potential difference between 2 points, which is AB, which is at a distance of RA from origin. The point A is at a distance of RA from origin, and point B is at a distance of RB from origin. Then the potential difference between that 2 points VAB due to the charge Q can be written as Q by 4 pi epsilon naught into 1 by RA minus 1 by RB. Now how to find what is the absolute potential due to this point charges? Now before going for absolute potential, I want to find what is the potential at point A. What is the potential at point A? What is the difference between potential and potential difference? So potential difference is when I move a charge from point B to particular point B to point A, then what is the work done to move that charge from point B to point A is termed as potential difference. Now the potential is I want to move a unit charge from infinite distance to particular point A, then that work done to move that infinite charge to that particular point A is known as the potential at that point A. So in this expression, so I have to bring the unit charge so at infinity to that point A, then this expression can be termed as expression for potential. So I can write in the place of RB, I'll substitute RB is equal to infinity, then the expression will be VA is equal to Q by 4 pi epsilon naught 1 by RA minus 1 by infinity. To find potential, I have to move a charge from infinite distance to that particular point RA, that particular point A. Then the work done to move that charge is called as potential at point A. So which is given by Q by 4 pi epsilon naught into RA volts. So Q by 4 pi epsilon naught into RA volts. Now, according to definition of absolute potential, so absolute potential which is measured with respect to fixed reference point means if I want to measure absolute potential at point A, then the absolute potential at point A can be given as this potential at A minus potential at reference point. The potential at A minus potential at reference point, that is VA minus V0, which is equal to VA minus 0, because V0 is 0 because fixed reference point has a 0 potential. So VA minus 0, so which is equal to VA. So which is equal to VA. So I can write absolute potential at point A can be written as the potential at that particular point, that is VA, which is equal to Q by 4 pi epsilon naught into RA. Similarly, we can write potential at point B can be written as VB is equal to Q by 4 pi epsilon naught into RB. So this is the concept of absolute potential. Absolute potential is the potential measured with respect to fixed reference point which has a 0 potential. So we can write absolute potential as VA is equal to Q by 4 pi epsilon naught into RA at a particular point A. Now, so previously we saw when your charge is placed at origin. Now if your charge is not at origin, see here. So charge Q is placed at a distance of R dash from the origin, and I want to find what is the potential at A. So which is at the distance of R from the origin. Now what is the distance between them? Q and A is given as R minus R dash, the magnitude of R minus R dash, which is taken as RA. Now the expression for potential will become VA is equal to Q by 4 pi epsilon naught, distance between this charge to this point, so R minus R dash, which is equal to Q by 4 pi epsilon naught into RA. This is the expression for the potential due to a point charge when that point charge is not at origin. Now, if there are multiple number of charges, multiple number of point charges are present like this. So, but these point charges are not in origin. The distance between the point charge to origin is R1, R2, R3, R4, small r1, small r2, small rn till n, if n number of charges are present. Now, and the point A is at a distance of R from origin. Now, to find the potential at point A due to all these charges, we will take the individual potential, that is potential due to Q1, potential due to Q2, potential due to Qn, and we will add all the potential. We will take individual potentials and we will add all the potentials. Such then we will get what is the total potential due to all these charges on point A. So we can write, see, the potential at A can be due to Q1, due to Q2, due to Qn. Like this we can add up and we can obtain the potential. What is VAN? VA1. VA1 will be using this expression Q by 4 pi epsilon naught, and distance between Q1 and A is R1. So VA1 can be written as Q1 by 4 pi epsilon naught into R1. Similarly, Q2 can be written as similarly VA2 can be written as Q2 divided by 4 pi epsilon naught into R2. Similarly, VAN can be written as Qn divided by 4 pi epsilon naught Rn. So simplifying this, you will get expression for this can be written as the summation m is equal to 1 to n Qm 4 pi epsilon naught into Rm. Rm is the varying from the distance from R1 to Rn. So Rm can be written as it is the modulus of R minus Rm, that is R minus Rm, that is R minus R1, R minus R2. So if you take magnitude of that, you will get Rm. So this is the expression for potential due to several point charges. So in this video we saw what is absolute potential and what is the potential due to point charge, which is at origin and which is at not origin. In next video we will see what is the potential due to line charge and surface charges. Thank you.